Session. My name is Ranbir. Hello everyone. Welcome to Cloud Overview Session. My name is Ranbir Singh and I'm part of Oracle Cloud University Delivery. Safe Harbor. In this session, I'll go over what is cloud computing, characteristics of cloud computing service and deployment models, benefit of cloud, and I'll also talk about cloud computing challenges, cloud management and administration. As cloud computing evolved in software industry, National Institute of Standard and Technology in United States documented the definition and characteristics of cloud computing. In simple terms, cloud computing is a model for enabling universal, convenient, and on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Let's discuss the essential characteristics, deployment models, and service models of cloud computing. The characteristics of cloud computing are on-demand self-service. On-demand self-service capability enables the users to use cloud computing resources without requiring human interaction, mostly done through a web-based self-service portal. Users can unilaterally provision computing, network, and storage capabilities as and when needed without requiring human interaction. On top of that, users should be able to monitor and manage computing resources from a single user interface. With rapid elasticity feature, resources are provisioned and released on demand and or automated based on triggers or parameters, which ensures the application has the exact capacity that it needs at any time. To the consumer, the capabilities available for provisioning often appear to be unlimited and can be appropriated in any quantity at any time. Broad network access will make sure cloud resources are accessible via the network. It supports different platforms such as mobile devices and workstations. Computing capabilities are available over the network and accessed through standard mechanisms. Measured service feature facilitates that resource usage is monitored, measured, and reported based on utilization. Measured service provides transparency for both the provider and the consumer of the utilized service. Cloud systems automatically control and optimize resource use by leveraging a metering capability for storage, processing power, bandwidth, and active user accounts. Resource pooling lets same physical resources be used by multiple customers by securely separating the resources on a logical level. The different physical and virtual resources are dynamically assigned and reassigned according to consumer demand. There is a sense of location independence in that the customer generally has no control or knowledge over the exact location of the provided resources. Users may be able to specify location like country, state, or data center. The resources can be pooled or storage, memory, core, and network bandwidth. Here are three service models defined by National Institute of Standard and Technology. Software as a service, SaaS, is where applications are delivered to the end user over the internet. Platform as a service, PaaS, is where an application development and deployment platform is delivered as a service to the developers, enabling them to quickly build and deploy a SaaS application to the end users. Infrastructure as a service IaaS is where computing hardware like server, storage, and network is delivered as a service. This typically includes the associated software as well, like operating system, virtualization, clustering, and so on. In SaaS model, the consumer does not manage or control the underlying cloud infrastructure, including network, server, operating system, storage, or even individual application capabilities. The resources are used based on the subscription model. Many businesses are finding SaaS to be the ideal solution because it enables them to get up and running quickly with the most innovative technology available. Automatic updates reduce the burden of in-house resources. Customers can scale services to support fluctuating workloads. A modern cloud suite provides complete software for every business need, such as customer experience, ERP procurement, ERP project, portfolio management, supply chain, and enterprise planning, to name a few. In platform as a service model, the provider will host the infrastructure and middleware components, and the customer accesses those services via a web browser or other APIs. The consumers have control over deployed application and the configuration setting for the application hosting environment. To aid productivity, PaaS solutions have ready-to-use programming components that allow developers to build new capabilities into their applications, including innovative technologies such as artificial intelligence, chatbots, blockchain, and Internet of Things. PaaS also includes solutions for analysts, end users, and professional IT administrators, including big data analytics, content management, database management, system management, and security. In infrastructure as a service model, the consumer does not manage or control the underlying cloud infrastructure. Consumers have control over operating system, storage, and deployed applications, and possibly the limited control of selecting networking components. The cloud subscriber is usually responsible for installing, configuring, securing, and maintaining any software on the cloud-based infrastructure, such as database, middleware, and application software. Now, let's look at various deployment models in cloud. Public cloud is defined as services offered by cloud service providers over the public internet, making them available to anyone who wants to use them. They may be free of cost or sold based on demand usage. Public cloud allows customers to pay only for the usage of CPU cycle, storage, or bandwidth they consume. In a public cloud, the whole computing infrastructure is located on the premises of the cloud provider. The benefit of public cloud is that customer does not have to maintain their own IT and can quickly add more users or computing power as needed, and the cloud provider has multiple tenants sharing its IT infrastructure. Private cloud is a service offered over the internet and with a private internal network. It is available to selected users instead of the public. A private cloud is used exclusively by one organization, and it could be hosted at the organization location or at the provider's data center. The benefit of a private cloud is that it provides the highest level of security and control. This model helps customers meet data residency and compliance requirements. A hybrid cloud is a computing environment that combines an on-premise data center with the public cloud, allowing data and applications to be shared between them, or in some cases, people define hybrid cloud to include configurations where an organization uses more than one public cloud in addition to their on-premise data centers. Generally, the customer will host their business-critical applications on their own servers for more security and control, while their secondary applications will be stored at the cloud provider's location. Multi-cloud meaning customer is using multiple cloud vendors. and using multiple cloud computing and storage devices in a single architecture. So behind the scenes, there are multiple clouds, but the experience is like using a single cloud. Here are some benefits of moving to the cloud. Device independence means cloud computing offers broad network access anywhere, anytime. The type of device an individual uses has no impact on cloud effectiveness. As long as a phone, tablet, or laptop connects to the internet, the cloud and its subsequent applications are available. Universal access means cloud resources that can be used on demand from anywhere and anytime via the internet. We have increased productivity and lower cost because cloud model is OPEX based instead of CAPEX. So there is no upfront cost for customers to set up and purchase infrastructure for every project. Most cloud computing services are pay-as-you-go model. You have increased productivity because team members can view and share information easily and securely across a cloud-based platform. Cloud-based services often offer extra bells and whistles like integrating social media capabilities, machine learning, AI, therefore increasing interest and engagement. When we move to the cloud provides the latest security technology, which has traditional data center security plus security services for access control, threat prevention, threat detection, threat mitigation, redundancy, legal compliance, and cybersecurity policies. With the cloud, we have increased data reliability due to cloud computing self-adjusting functionality, meaning less downtime and better allocation of resources. Cloud computing reduces the recovery time after an attack and allows companies to increase redundancy. In the event that a server goes down, multiple servers are ready to pick up the burden of the operation, all in a very short time window. Furthermore, storage space can be expanded without the need to contact a third party, meaning less hassle and less time wasted on managerial tasks. With the cloud, we have easy governance and control because we know any change to the business process or technology platform introduces risks. Using management cloud services, we can develop policies for cost management, security, and resources consistency. Cloud solution is a complete and integrated solution due to fast and reliable data synchronization, which also eliminates redundant data and improves operational efficiency. Cloud offers easy migration. It supports 6 hours of migration where you can rehost, replatform, repurchase, refactor, retire, or retain. This means customers can preserve existing investments. At the same time, when you move to the cloud, you can enrich and extend your existing applications. Cloud computing applications get updated automatically for software updates, resulting in new features available as they are released and ensuring round the clock maintenance of cloud servers, including security updates. When an organization decides to migrate to cloud, there might be many challenges and factors that need to be taken care of. The first one is interoperability, in which the cloud environment must be interoperable. Users should be able to run the app on different devices and integrate other cloud services to the existing infrastructure. The second is performance. As the number of users increase or the size of the application increases with a greater number of programs or components, the user must not face any performance issue. The third factor is reliability. Any deployed cloud application must work without single point of failure. The fourth important factor is security of the program and the code. Client-side security and data storage protection security must be implemented. Cloud apps may include numerous API-based integrations that we have to protect for. The last factor is scalability. The cloud-based app should not crash because of sudden traffic surges of many users or sudden spike in activity. The system should scale to meet the demand. Here are some of the common tasks for cloud management and administration. Cloud provisioning is the allocation of a cloud provider resource and services to a customer. Orchestration is the automated configuration, management, and coordination of computer system applications and services. Cloud automation is the practice or discipline of using specialized software tools and methodologies to automate some or all of the manual tasks associated with managing and operating cloud-based IT infrastructure. Cloud compliance means configuring systems to be compliant with the standards that are requested by the end users, industries, and government. Service request is a formal request from a user for something to be provided. Cloud monitoring is a method of reviewing, observing, and managing the operational workflow in a cloud-based IT infrastructure. Manual or automated management techniques confirm the availability and performance of websites, servers, applications, and other cloud infrastructure. Logging is a model for centrally ingesting and collecting any type of log files coming from any given source or location, such as servers, applications, or devices. Inventory and classifications are insights and visibility about services to empower customers manage the environment effectively. And cost management and optimization means keeping your budget under control. Price is a big parameter in favor of starting your journey to the cloud, and it usually starts nicely. But soon as your environment grows and as you start moving production workloads to the cloud, controlling cloud costs is the most common challenge people encounter. It also means optimize your cloud performance and cost ratio. Cloud lives on the promise of scalability and the possibility to scale up or down horizontally as the demand increases or decreases. And these features need to be carefully planned and configured. In this session, we learned about cloud computing, characteristics of cloud computing, cloud service and deployment models, what are the benefits of moving to cloud, what are the challenges in moving to the cloud, and finally, some key management and administration tasks. I hope you enjoyed the session. Thank you.
So if you're wanting to successfully manage multiple businesses, well, it requires that you segregate them by their strategic objectives and measure their results. So what we're talking about here is your divisions, your lines of business in your enterprise, even it could be a business unit. Now, although it's related to your legal structure, the business or managerial organisational hierarchies don't need to be reflected directly in the legal structure of the enterprise. And as I just mentioned, they could be divisions, subdivisions, lines of business, strategic business units, cost centres. And in the cloud applications, the management structure is implemented using divisions and business units as well as being reflected in the chart of accounts. So on to our final structure, which is the functional structure. So this is a functional organisation structured around people and their competencies. So you can see here we have things like sales, finance, the IT team. These are all functional organisations, so it's where the people are. So if I was an accountant, for example, I would be part of the finance team. Now, the functional structure, these teams, you're going to reflect the efforts and expenses of these organisations on your income statement. So all of these teams, they're going to have to manage and report their revenues, their cost of sales, their shared services? Do you have a shared service department? So do you have somewhere that maybe HQ that does all your procurement? Or does everybody do their own procurement? So where are you on the spectrum of centralisation versus decentralisation? So these are important questions that are there to help you think while you're planning your implementation. And we're going to carry on with them actually, because we've got a few more for you here. So looking at security, Jen, what access are you going to give your users? Will they have access to a single ledger if they're working in Jeopardy? General ledger, and a single business unit if they're working in payables or receivables? Or will they require access to multiple ledgers, multiple business units? Now within general ledger, you can actually allow somebody access to a specific primary balancing segment value. So this is